Hello everyone. In this video, I'm only going over two problems from the homework assignment from last week, numbers 31 and 34 from pages 204 and 205. I feel 13 and 14 are pretty self-explanatory with the solutions I posted, but still, if you have questions over that, just email me. All right, so looking at number 31, the description here says, this graph shows the graphs of the first and second derivatives of a function y equals f of x. You're to work in groups of 2 or 3, copy the figures, and then we want to add a sketch of a possible graph of f that passes through the point P. So the easiest way to do this is to create a sign chart for each graph. So what's in blue here is the first derivative. So I want to just go ahead and write out a number line, label it f prime of x. And it doesn't give us actual zeros where it's passing through, but I'm just going to call the first one A and the second one B, so those would be the critical numbers. And I know my first derivative is above the x-axis from negative infinity to a, so it's going to be positive right here. Then it dips below the x-axis, so then it's going to be negative, then it's going to be positive. So what I know about our function f right now is that it's first increasing, then decreasing in the middle, and then increasing again. And then we can make a second derivative number line. Now here I see that it's just this line that definitely goes through the origin, so 0 is my critical number. Now before x equals 0, my second derivative is negative, and then on the other side it's positive. So this tells me my function f is concave down and then concave up. So now when I go to draw my graph, I'm going to put the value of a right over here, right about the same spot that a is marked here, and then b over here, and then I have 0. But it has to go through point P, so I definitely want to keep point P up here. So I know my function is first increasing before a, and it's concave down, and it has to pass through point P. So if we're increasing up to point A, if I started it down here, we're going to decrease afterwards, so I don't want to start it down here. So I might want to start it above P. So let's say I'm going to hit, if I'm increasing and decreasing, I'm going to hit a max value over here over A. And we know we're concave down, so we're increasing, and then we're decreasing, and we have to go through point P. And right there, we would say f of 0 has to equal P. So this is also going to be our point of inflection right here, or the y value of our point of inflection. So I'm increasing up to x equals a, decreasing after it, I'm concave down the whole time. At point P, or 0p, this is where our concavity changes. So now I'm still decreasing before we get to b, but now we're concave up. So I'm going to have a min, and I could go here, I could make it go a little bit downward, even more. Let's just say we're going to make our min right here. So we're going to be concave down, and then we have to start increasing afterwards. So there's a possible sketch for our graph y equals f of x. All right, now when we look at 34, it says f is an even function, is continuous on the closed interval from -3 to 3, and it satisfies the following. Well, even functions mean our graph is symmetric with respect to the y-axis. So that information is going to be extremely helpful. Again, we're going to make our two number lines here. So first I want to do my first derivative number line. And if we go across here, we know it's going to go from -3 to 3. And this is just going 0, 1, and 2. So I'm going to start my 0 right here because our first derivative doesn't exist, so that's a critical number. It's also 0 at 1, so that's a critical number, and then 2. If we go over and look at our sign chart, we're going to have negative, negative, and positive. Now, if we think about, and what we could really do is we could leave this part empty right now until we go to graph it, then we can use the symmetry. But if you think, if you're on one side of the x-axis and you're increasing, and you go to flip that over the y-axis, you're going to be decreasing. So technically we could fill this in, but you're going to see it more when we go to bring the whole graph together. So if we're at -1, -2, we're going to be just the opposite should look like that. And then we'll go ahead and make a number line for our second derivative. And if we look here again, we know we're going from -3 to 3. We'll still have 0 in the middle, so 0, 1, and 2 are still our critical numbers for our second derivative. And then if we look between 0 and 1, we're positive, and we're negative, and we're negative. So this means we are concave up. So F would be concave up, concave down, concave down. Now concavity reflects the same. So if we're concave down on one side, we're concave down on the other side. So when we go to write in -1, -2, we're going to have the same signs repeat here. So it'll become plus, minus, minus. And then over here, let's just kind of write this in that F will be decreasing, decreasing, and then increasing. All right, so as we go to draw our graph, let's do 1, 2, and 3 over here. -1, -2, -3 over here. And if we go back to our first chart, the highest number we get to is 2. We go down to -1. All right, so we know, let's go ahead and plot these points here. 0, 2, 1, 0, and then 2, -1. And if we take a look at our graph, we know we're decreasing, and then we're going to be concave up. So between these 2 points, we're decreasing, we're concave up, so it looks like this. Between 1 and 2, we're still decreasing, but now we're concave down, so it turns like this, decreasing and concave down. Now we're increasing from 2 to 3, but we're still concave down. And this can go in any direction. Since we don't know what the x value or the y value is when x is 3, we can make it anywhere. I'm just going to bring it up to here. We'll say something like that. So we're increasing, but we're still concave down. Now the symmetry applies over here. So we're just going to reflect this over the y-axis. So we're going to still be here and then here. So notice we're going to be increasing though, but we're still concave up. So it's going to look like this. There's that symmetry. We're still going to be increasing, but we're also still going to be concave down. So it's going to look like this, increasing, concave down. And now we'll be decreasing, but we'll be concave down again. So the symmetry to our graph would just be right there. So that's what our graph looks like. So there were problems 31 and 34. If you still have questions, just shoot me an email.